Hello and welcome to my presentation. In silico modelling has been performed to assess the impact of three inhalation variables: breath profile, actuation delay and breath hold. Two example products were studied, an MDI and an SMI. Predictions of regional lung deposition were performed for each product using the software Preludium. Summary data for the analyses performed and literature references are also included as appendices to this presentation. Okay, so how does the software work? Deposition is determined for each generation of the lung in series for the inhalation, then the breath hold, then the exhalation. Deposition percentages are then determined for the complete breath for each generation, and then this is computed to the regions of the lung. Exhaled fraction is also determined at the same time. Penetration index can then be determined from that regional lung deposition, and that gives an indication of the deep lung deposition. I would also like to acknowledge the input of Bo Olsen on setting up of these models and for the use of these images within this slide. In terms of the model setup then, that was based on advice from the supplier, but also a significant amount of literature publications. Coarse deposition for the extrathoracic region was determined from in vivo studies of the Respimat and QVAR products. Simulations were then performed for a matrix of the three factors. 12 experiments in total were performed. Regression analysis was then performed on that data for both penetration index and exhaled fraction. And that analysis was done to determine the relative impact of the three factors and whether there were any interactions between them. So on to the results. So here we've got a slide showing results for the soft mist inhaler in terms of the exhaled fraction. And you can see from the Pareto chart on the left-hand side that breath profile and the delay time are the two most significant factors. On the right-hand side, we have a data plot showing the interactive effect of those two factors, which shows a vast increase in exhale fraction for a short breath profile with a long actuation delay. This is an extreme case where the tail of the bolus is emitted very proximate to the end of the inhalation profile. Otherwise, the exhaled fractions simulated have been very low. We have, though, been unable to confirm the accuracy of these predictions, as there is no in vivo data available for this specific product. In terms of the penetration index then, again, the breath profile and the delay time are the most significant factors. And again, there is an interaction between them. And here we've highlighted the case of a standard breath profile with an elongated delay. And again, the reduction in penetration index is due to the proximity of the tail of that bolus from the product to the proximity of that to the end of the inhalation maneuver. In this case, though, it's not due to an increase in exhaled fraction, it's due to an increase in upper lung deposition. And it is considered that such variability in penetration index, depending on the actual product and molecule, may impact the uptake of the drug within the lung and then perhaps the Cmax within the PK profile. It is clear from the simulations run that a long breath profile with a reduced peak inhalation flow is preferable in terms of increasing the penetration index, and that is due to increasing the residence time of the plume or bolus within the lung and increasing the sedimentation of the drug. So now onto the MDI, again starting with exhaled fraction. We can see for the MDI that the analysis shows that breath hold was the most significant factor. However, from comparison to some published in vivo data for the QVAR product, we consider that the model overestimates exhaled fraction unless an extended breath hold time is used. Again, though, a long breath profile is preferable along with a reduced delay time. And in both those instances, that results in increased residence time of the drug within the lung, increasing the deposition from diffusion and reducing the exhaled fraction. So finally, in terms of the penetration index results for the MDI, again, we have this issue with the hold time. However, it is likely that an extended hold time is preferable in terms of penetration index. We've highlighted instead the case of the variability within the breath profiles, which again could have an impact on the uptake of the drug, depending on the drug and potentially the PK profile. Again, a long breath profile is preferable with its reduced peak inhalation flow. This will reduce deposition within the upper regions of the lung, and it will also increase the residence time for diffusion deposition and reduce the exhaled fraction. Finally, it's worth noting that the penetration index for the MDI is approximately 10, which is much greater than the predicted penetration index for the SMI. And that's due to the significant difference in the input APSD. The MMAD for QVAR is much reduced compared to Respimat. So in conclusion, variability in these inhalation profile factors may have a significant effect on the inhaled drug, on the fate of the inhaled drug for both SMIs and MDIs. And from the analysis done, we can give indications in terms of the optimum conditions for deep lung penetration. And certainly an elongated breath profile seems to help with that. I think there are significant potential improvements to the modelling in terms of factoring in the delivered dose and certainly the throat deposition, and ultimately wanting to model the PK output, which the software is capable of. Thank you very much for listening. That concludes the presentation. Please contact me if you have any questions.